All right, so we are going to move on to inverse functions. We're going to spend 2 days on this. We're going to start with a lot of definitions, and then we'll move on to what you're probably more familiar with inverse functions, which is the actual solving. So the first thing we want to do, get ourselves ready for notes, and we're going to get started. When we talk about inverse functions, it's really important to recognize that we're talking a lot about what's called one-to-one functions. Now, one-to-one functions are functions that not only pass the vertical line test, which all functions must do, but they also pass the horizontal line test. So a function that passes the horizontal line test would maybe look like this, where every time you draw a horizontal line through it, just like the vertical line test, it only crosses once. Now, a lot of graphs that we have been talking about a lot don't pass the horizontal line test, such as here, where we see it crosses twice. So this one would fail the horizontal line test. Quadratics are not one-to-one. Now, this is really important for what we're talking about here because only one-to-one functions have inverse functions. They might have inverse relationships, they might have inverse curves on a graph, but they're not going to have an inverse function. And so one of the first things we want to look at is let's make sure we recognize which functions are one-to-one and which aren't. So if I'm looking at this list of 4 things over here, I'm going to ask myself, which of these are going to have inverse functions? Which of these are one-to-one? Now, as we just said, quadratics are not one-to-one, so they do not have an inverse function. This first f of x has a degree 2, so we are not going to have an inverse function. G of x is x cubed, which is the graph that we saw here first. X cubed does have an inverse function. Now, 2 root x, if you graph this on your calculator, or I'll graph it now, it's going to look like this. So it's like half of a sideways parabola. It also passes the horizontal line test. Now, j, these absolute values, remember, the graph of absolute value looks like a V. So this does not pass the horizontal line test and does not have an inverse function. Now, inverse functions we have here, given f is a one-to-one function, so it's going to have an inverse function, then, and f of 3 is equal to negative 7, find f inverse of negative 7. So let's just review that notation. So an inverse function here is a function that cancels out f, and it would be written as, it looks like an exponent, but it's not. Okay, so we've got this. Now you might say, this feels like a lot of weirdly connected information. Well, let's dissect it a little bit. Now f of 3 equals negative 7 means that 3, negative 7 is on the curve f of x. We reviewed this a little bit in the first lesson of the week. Now, what most students do remember about inverses is that they switch x and y. Well, if we look here, we have 3 as an x value and negative 7 as the y value. So therefore, the inverse function will have negative 7, 3 on its curve. Because we're switching x and y, we're reversing the order. So instead of 3, negative 7, we have negative 7, 3. Therefore, if I ask what is f inverse of negative 7, well, that's 3 right there. One other really important fact about inverse functions, which I alluded to in the last lesson, is that when you compose a function and its inverse, they will cancel out, meaning that no matter what order they are in, we are going to end up with just the variable on the other side. They cancel out, they undo each other, and we just end up with x. So for 3, it asks, use the inverse function property to determine if the functions f and g are inverse functions. So what that means is that we want to know if f of g of x is equal to x. So we will plug those in and see. So f of g of x, and you could do them in either order, you just got to pick one, would be 2 times parentheses the cube root of x plus 1 over 2 to the third power minus 1. So the first thing I'll do is see if this equals x. We're going to remember that cube root and cube cancel out. They are inverse operations. And we're left with 2 times x plus 1 over 2 minus 1. Multiplication and division cancel out because they are inverse operations. You'll notice using inverses a lot here. Then we have x plus 1 minus 1, which will these will cancel out. And we're left with just x, meaning that f and g are in fact inverses. Let me know if you have any questions about this introduction to inverses, and I'll talk to you later.